This is a quick mini lesson on how to simplify fractions using a very cool trick. You're going to use this quite a bit if you feel comfortable with it working through the probability unit. So I wanted to kind of show you how to do this. So this little trick applies whenever you're multiplying fractions together. Now, we know that we can always multiply a fraction by multiplying the numerators together and then the denominators together. So let me show you this first example, and then I'm going to kind of backtrack and kind of show you the trick. So if I were to simplify, or if I were to go ahead and calculate these two fractions, 1/3 times 4/8, I would multiply 4 times 1, which would give me 4, and then I'd have to multiply 3 times 8, which would give me 24. And you can see that that fraction that is our answer is not simplified. So I'd actually have to simplify that down to 1/6. So this is one way you can do it, and this is absolutely fine to do this, this method. But I wanted to show you a trick because sometimes when you get to this point right here in the problem, these numbers can be kind of tricky to simplify, and it could really require some work to get it down to its simplified form. So I want to show you the trick. So let me go ahead and erase this, and then we're going to show you how to do this. All right, so here's what I want to do. I want to do something called cross-simplifying. In this first example, this is a very basic example. Before I get to my answer, I notice that my 1/3 fraction is already simplified, but my 4/8 fraction is not. So before I compute the answer, I'm going to go ahead and simplify 4/8. That simplifies down to 1/2. And I'm just going to cross them off and put the little numbers next to it. Now I can see that both of my fractions are simplified. So now I can go ahead and now I'm going to go ahead and multiply the numerators and denominators. So 1 times 1 is 1, and 3 times 2 is 6. So you can see that I'm still reaching the same exact answer, but I'm doing it in another method. I don't have to simplify at the end. All right, let's go ahead and look at another one. This one's slightly different. I have 2/5 times 3/8. So if I want to simplify 2/5, I can't because I don't have a number that both numbers are divisible by. Same thing with 3/8. But I do have a 2 in my numerator, and I do have an 8 in my denominator. I can actually simplify by crossing. So it's called cross simplification. So I can actually take that 2/8 and kind of pretend that they're on top of one another in one fraction. And I can say, well, both of these numbers are divisible by 2. So I'm going to simplify the 2 into 1, and I'm going to simplify the 8 into 4. Now I can just kind of look at my fractions again and see if there's anything else that I can simplify. Since there's not, I'm going to go ahead and multiply straight across. So 1 times 3 is 3, and 5 times 4 is 20. And if you use this little trick, it will give you your final answer in simplified form, so you don't have to simplify any further. All right, this is a really cool one. Now let's look at this, 2/9 times 3/10. You can see that 2/9 is not divisible by any number that's common. And 3/10, same thing, not divisible by a common number. But my 2 in my first fraction and my 10 in my second fraction are divisible. And then my 9 in my first fraction and my 3 in my second fraction are divisible. So if I look at the 2, I can simplify that down to 1 because I'm dividing it by 2. I can also divide the 10 into 2, and that will give me 5. Now, those two numbers are as simplified as they can be. But what about the 3 and the 9? Couldn't I cross off the 3 and say 3 divided by 3 is 1, and then 9 divided by 3 is 3? So I simplified it before I even computed. Now, go ahead and solve. 1 times 1 is 1. And then 3 times 5 in my denominators is going to be 15. So I have a simplified fraction. Now, let's just kind of go backwards here for a second. Now, what would happen if you didn't do this process? So if I didn't do this process, I would get an answer like this. My numerators would be 2 times 3 is 6. And my denominators would be 9 times 10 is 90. And I would have to take 6 divided by 90 and simplify that down to 1/15. So this is just an easier way to simplify. All right, now what if you have 3 fractions being multiplied together? Does it still work? Well, it does. It's kind of cool too. You want to find numbers that are divisible by a common number. So the first number I have is 7 and 14. I can say that 7 is divisible by 7, so I'm going to put a 1 there. And then 14 is divisible by 7 twice. Now, notice the 6 and the 3. I can jump across fractions as well. I can say that 3 is divisible by 3, and then 6 is divisible by 3 twice. And then my last one, I have 5 and 20. So 5 divided by 5 is 1, and then 20 divided by 5 is 4. Now that I've simplified everything, nothing else can be broken down. I'm just going to multiply the numerators and denominators. So 1 times 1 times 1 gives me 1. And then my denominator, 2 times 2 gives me 4. And then 4 times 4 gives me 16. So I don't have to do any simplifying. It's already done for me. Here's one with 4 fractions. Still works the same way. Try to find the numbers that have a common factor they're both divisible by. So I'm going to start by kind of just jumping around. Now, I'm going to actually start this one by looking at what I can simplify in the same fraction. So you can see it, the 6 over 9. I can actually take that and simplify it, couldn't I? Couldn't I make that 2 over 3? You can work this way, or you can work diagonal from each other. Either one is fine. I can also simplify the 4/10 down to 2 and down to 5. Now, let's go ahead and jump around here. I have a couple things that I could do here, but I'm going to go ahead and start with the 3 and the 12. 3 is divisible by 3 once, and it goes into 12 4 times. And I also have the 5 in the numerator, and I have the 5 in the denominator. So I'm going to cancel that out and make it a 1. And I'm going to cancel this 5 down here and make it a 1 as well. I also have a 2 and an 8, so I can cancel out the 2 and make it a 1. And I can cancel out the 8 and make it a 4. Is there anything else that can be simplified? And the answer is yes. The 2 in the numerator can be simplified with either one of the 4s in the denominator. So I'm just going to pick one of the 4s and say that 2 divided by 2 is 1, and 4 divided by 2 is 2. Now all my numerators are 1, so there's nothing else I can reduce it by. So my numerators, 1 times 1 times 1 times 1 will give me 1. And 2 times 3, that's going to give me 6. 6 times 4 is 24, times 1 is 24. So I'm done simplifying. So you can do the simplifying ahead of time, or you can do it afterward. So I want to kind of show you what this one would look like if I did it ahead of time, or if I didn't simplify ahead of time. If I just multiply the numerators, it would be 3 times 6 times 5 times 4, which would give me a numerator of 360. My denominator would be 8 times 9 times 12 times 10, which would give me 8,640. And then I would have to go and reduce that to 1/24. Personally, I think it's easier to reduce beforehand versus reducing afterward when you have those big numbers. So feel free to use this helpful tool as you work through the probability unit.